A V?
A V. Thank you, Gabby. So the graph should look like a V. Hopefully you were able to see the graph looking like a V as well. So the graph of an absolute value, y equals absolute value of x, is a V. The tip of the V is at 0, 0, which we know is the origin. And, oh, that side didn't connect. There we go, close enough. This is what my graph should look like. So if I graph y equals the absolute value of x, it should be a V. So absolute value, we talked about having that positive and negative side when we're solving an equation. The reason there's a positive and negative side is because my graph has a positive line and a negative line. So that's what creates the V. It's the same line, but it's two lines connecting together with the same slope. So that's how we get that V, and that's why when we're looking at the equation, we actually have a left and a right side of the equation, the positive side and the negative side, to account for the V as well. So the next part of this then, working just with this same thing, the goal is to see what happens when you add a number. So we have this absolute value of x, thank you. And then it says plus k. So we want to see what happens to this graph. We want to describe how the graph changes when we add a 2, or when we add a 5, or when we subtract a 3. So that's the goal of this first example. What happens when you add a number outside of the absolute value? So if I add a 2 or I add a 5, let's talk about that part first. Annabelle, do you know what happens to the graph if you add that plus 2 after the absolute value or the plus 5 after the absolute value?
Like the point would increase on the y-axis.
Yeah, I like that. The point increases on the y-axis. So if it was plus 2, maybe it's up here now on the y-axis. So it's moving up the y-axis. But the graph should look the same. The shape of the graph should not change. So it moves it, it increases it on the y-axis, and we kind of say that we like to say it moves it up. The plus 5 is even going to move it up further. So if it's plus 5, it even goes up further. Annabelle, what happens with the minus?
It will go down.
Yeah, it's going to go down. So it falls on the x or the y-axis. It goes down. So the minus 1 would go down. So if you graph these in your calculator, this is what you should have ended up seeing. So you have all these V's on the graph, but the key thing is to think about what happens with it. So I'm going to write in general over here because we're going to be using this today. When I have a plus k, so a plus 3 or a plus 2 or a plus 5, that graph moves up. The y-axis by whatever number that k is. So by k units, whether it's through 2 units or 5 units or 7 units. When it's a plus k, it's going to go up. When it's a minus, then the graph moves down the y-axis by that k value. So that's one thing that we can kind of generalize. When you see a number outside, we got the absolute values, and it's a plus something, then it goes up. If it's a minus something, then it moves down. And we're going to focus on that throughout the entire year once we start changing our functions. So that's kind of just something to think about. All right, let's look at the next group. So again, we know that we have this absolute value. And you were asked to graph the absolute value of x. So that's the original function. We call that our parent function. So I'm going to graph it again. So here's starting at the origin, it's still a v. All right, So this problem says what happens now if you take that x inside the absolute value and you have a minus 2, or you take that x inside the absolute value and you have a minus 4. So we're looking at the two that say minus. Does anybody know what happened to those two graphs when you have y equals the absolute value of x minus 2 or y equals the absolute value of x minus 4? Jaden, do you know what happened to those two graphs?
Like, do you mean like it would go down on the graph because they're negative, and then like for the -2 and -4?
So if you
Sorry,
look,
I'm kind of confused.
no, you're good. If you look at the difference from the one we just did, so the one we just did had a number outside the absolute value. That's what moved it up or down, because it's outside and separate. So this is going to do something different because now the number is inside the absolute value. So it's trapped inside those absolute value bars instead of being separate from it. Faith, do you think you could help her out? Do you know what happens with these two graphs?
The V moves on the x-axis.
Yeah, I like how
up
you
or
said that
down.
too. The V, yeah. So the V is going to move on the x-axis. So if I had y equals the absolute value of x minus 2, this graph actually moves on the x-axis to the right. So it's going to move on the x-axis 2 units right. So instead of moving up, it's moving right. And the reason it does that is because it's with x. So it's trapped inside with x. So whatever x does, well, x goes left and right, then it has to do as well. So it's going to move right. The other one, x minus 4, is also going to move right, but it's even going to be right further. It's going to be over here. So we still have these v's, but they're moving right. So I'm going to make a little summary over here. When I have x minus h inside, so when it's trapped inside with x, it's moving the direction that x goes. This graph moves right on the x-axis by h units. And we're even using a different letter. So up above we used a K. So K tells us it goes up and down. In this problem we're using an H. So all these letters that we're thinking about here, but there's an H in this problem. So the other question you were asked to graph was y equals the absolute value of x minus 5. Or x plus 5, I'm sorry. Y equals the absolute value of x plus 5. Valerio, what do you think happens with y equals the absolute value of x plus 5?
The V will move to the left.
Yeah, it moves to the left. Did you know why it does that?
No.
So if you look at the original equation that they give us in the problem, the original equation says y equals the absolute value of x minus h. That's called a standard form of an equation. The minus sign is part of the formula. The h is totally separate. So this h guy is totally separate. The minus is part of the formula or part of the equation. So the reason that when it says minus x minus 2 and x minus 4, the reason it moves to the positive value is because you're only looking at the positive number 2 or the positive number 4, because the minus is in the equation. So Valerio, if this says x plus 5, and I wanted to actually change it to a minus sign, this is really saying x minus what?
-5.
A -5. So why does it move to the left, Valerio?
Because the actual value is -5.
Yeah, the actual value is -5. So that's really weird to think about. And we're going to talk about that when we look at our graphs today, but the actual value is -5. So the minus is part of the formula, it's part of the equation. And if you see a plus there, it's really saying x minus, and then the value is -5. So we're going to make a little summary about this as well, and then we'll move on to the last option there. So when it says x equals, or y equals the absolute value of x plus h, then it moves left. So essentially, it has to go the opposite direction when it's with x. So it might say x minus h, but it's really moving to the right because it's just the h value. It's just the number that we're looking at. The minus sign is part of the equation. Questions? All right, so we're going to go one more. There's one other option. And then we're going to kind of try and pull this together and look at graphing this on our own to see what all those numbers do. So this says describe the family of absolute value where we plug a number in front of it. So instead of having it inside squished in with x or outside totally separate being added or subtracted, we're now looking at the number being in front. So what happens when that number is in front? So here's my regular graph. So the first one asks you to plug in a 2, and then it asks you to plug a 5 in front of the absolute value. Does anybody get this to graph and kind of describe what happens when there's a number in front, like a 2 or a 5? What happened with that V? Faith, what happened with your V?
It got narrower.
Yeah, I like that. It got narrower. Which one was more narrow, Faith? The one with the 2 or the one with the 5 in front of it?
The one with the 5.
Yeah, the one with the 5. Why do you think that's the case? That's a crappy line.
Probably because, I don't know.
That's the slope. So that number in front's the slope, and my lines are looking wiggly. I'm trying to rush, and I shouldn't rush. Haste makes waste. That's what they say. So when there's a number in front, it gets narrow when there's a whole number in front, a 2, a 5. So when this number is bigger than 1, it gets narrow. Faith, I'm going to pick on you one more time. What do you think happens when the number is a half, a fraction?
It gets wider.
It's wider, yeah, and again, that's because it's the slope. I'm going up 1, but now I'm going right 2. I'm moving to the right further than I'm going up or down. So that graph gets wider. And when we say something's a fraction, we say the number is between 0 and 1. That's what fractions are, between 0 and 1. 1/2, 1/3, 4/5, 5/8. Any number between 0 and 1, it gets wider. So what I would like you to do is to take out your notes. We're almost at the very end of chapter 2. It's actually the last section, but the last section has 3 parts to it. So we're going to look at absolute value. We're going to look at transforming any kind of function. We're going to look at domain and range. Actually, it has 4 parts. And then we're going to look at piecewise functions. So this last section actually has a ton of stuff in it. In your packet, if you can turn to page 23. Ava, question?
Yeah, I'm sorry. I'm really confused. So, like, with the calculator, I was trying to do this last night, and it just, like, wasn't working for me. Could you just explain, like, how to do it on the calculator?
Yep, let me just, I don't have my calculator up.
Sorry.
No, it's okay. I had to shut down my MacBook because they were telling me that it wasn't working right, so they told me to shut it down. So, of course, that meant everything had to be shut down. Not your fault at all. I should have had it up and ready. That's their thing, their reason for everything. If it doesn't work, they're like, oh, just shut your MacBook down, restart it. That's why something doesn't work. I think they think I'm crazy. I could be crazy. All right, so let's see here. That you can see my screen. Okay. All right, so the first thing in your calculator, you need to hit second y equals. And we need to make sure our stat plots are off. So you can see that mine says off because yesterday when we were taking our quiz, they were on so that we could create a scatter plot. So you need to make sure that it says off. That's step one. The second step after you do that would be to go to window and make sure that the window says -10, 10, 1, -10, 10, 1. The rest of it doesn't matter. It's those first 6. These first 6 are what we were changing to graph the scatter plot. Do you have that, Ava?
Yeah, I did that part.
Okay, good. I just didn't want to go too fast.
No,
Okay,
you're good.
so
Sorry.
then we're going to go to y equals. Let me clear out my function that I was graphing. We're going to hit the math button. Julia, question.
On the window part, it won't let me change it to -10. Like every time I hit enter, it like says error.
Okay, if you hit the zoom button at the top next to window and hit the number 6 and then go back to window, it should have changed it automatically for you.
Okay, yeah, thank you.
You're welcome. Any other questions? Okay, so when we're in y equals, we're going to go down underneath y equals. It's the third one under y equals. You're going to hit math. And then you need to use the right arrow key, which are those gray circle keys. And I need to highlight number, N-U-M. And here is absolute value, ABS. And if I hit enter, now I have absolute value bars in my calculator. Your calculator, depending on the age of it, might not have the absolute value bars, and instead it might say ABS and then parentheses. That's okay. The parentheses represent the absolute value bar. Just depends on the calculator that you have. So then I would type an X into the calculator, which I know is next to the green alpha. And then I'm just going to hit plus, I think the first one was +2. And then you hit graph.
Okay, thank you. That makes a lot more sense.
You're welcome, no problem. Any other questions before we start moving into the notes? We actually will not be using the calculator today. You can use it to help like check to make sure you're correct, but we're not going to be using the calculator to graph today. We'll be graphing it by hand so that we can like mentally think about what's going on with the graph. Any other questions? Ava, I'm glad you asked because I'm fairly certain you weren't the only one. Probably 12 other students had the same question. Okay, so I'm going to go back to the iPad screen and we're in the notes. We're going to do a quick little review of absolute value, which we solved in chapter 1, and we said that the absolute value is a distance a number is from 0. And we looked at the number line. Here's the value of 0, and then I could have any number. I'm just going to say a C, a constant. And I know that that distance is the same on either side of 0. And that's how we have that plus or minus. That's how we get the two different sides of the absolute value. The absolute value function, so we talked about a function, each x has exactly one y, is of the form f of x. So it's saying that this is a function, it passes the vertical line test. Each x has exactly one y. Is of the form a, that a is the value that squishes it and makes it narrow, or spreads it apart and makes it wider. And then absolute value, inside we have that x minus h. Remember, h is the actual number. The minus is part of the formula or the equation, the way we write the equation, the way we write the function. And then we have plus k. K is the other number that we're going to be focusing on. So an absolute value function, it's a function because it passes the vertical line test. Each x has one y. And then this function has a couple of different letters in it that help us determine what's going on with the graph. You will see that the form of this function we will use in chapters 4, 5, 6, 7, and 8. So the way this is written with an A, the H, the K, that'll be the standard form of every equation that we look at. So you'll get to see this a lot throughout the year. Absolute value has something that we call a vertex. That's where the two lines meet to form the V. That vertex is going to be the highest or lowest point. And I need a T there for point. Because it's a point, it's an ordered pair. The H and the K value are the vertex, or create the vertex of the absolute value graph. So those numbers that we were using to get the graph to move up or down, or to get the graph to move left or right, they actually give us the location of the vertex. So where does the vertex get graphed? Because we're going to graph that part first. So if you look at the graph that's below, this is the parent function. Remember, the parent function is the most basic function. It's the function that doesn't move left or right. It doesn't move up or down. It just is a regular basic graph. So this is the parent function of absolute value of x. It has a vertex at the origin, and then it's saying that the slope of the line on the right, so this slope is +1, because that line is y equals +x. On the left, I can see that that's a decreasing line. Its slope is -1. So that's a characteristic of an absolute value function. It's really two lines connecting together with the same slope, but one being a positive and one being a negative. We have two more words that we're going to talk about, and these are kind of geometry words. The one word is a transformation. The transformation is the big group. Think about all the shapes last year that you did and how you transformed those shapes. You could transform them by their size, by the shape, by the position, or by their orientation. The one that we are going to look at is called a translation. And this is a shift of the position. And it shifts the graph horizontally or vertically. So a translation is shifting the graph. It's moving the graph, but it's not changing the size or the shape. So we're going to be shifting the graph using that H and K. The last thing that we can also do with a graph is change its size. That's just a transformation. It's not a translation. So translation, think like it's translating its graph. It's moving or sliding its graph or its vertex. So we already talked about this. when the number is bigger than 1, so we're talking about the number in front of A. This was the last part that we looked at in that little activity with the calculator. And I think Faith helped us with this one. So when the number in front is bigger than 1, the graph is called a vertical stretch because it is more narrow. And that's because the slope is getting steep. So it's pulling vertically. We call it a vertical stretch. It's getting higher and higher and higher on the y-axis, or getting higher and higher and higher for the y values. When the number is less than 1, that number in front is now less than 1, then we call it a vertical shrink. That means the graph is actually getting wider. So bigger than 1, it stretches because my slope is steep, so I'm pulling it vertically. Less than 1, the graph actually shrinks because it gets wider. So if a graph is shrinking, it's getting wider. I could use those two values kind of interchangeably, those two words interchangeably. And then the last type of transformation that we're going to look at today is a reflection. So we're not going to do any rotations. We are going to do a reflection. And a reflection simply flips the graph. So I know that's a lot. I mean, I just told you a whole bunch of different things. The reason I spent so much time on the calculator, kind of that activity that you were asked to do last night, explaining all the pieces, is because hopefully we can pull them together and now try and graph this. So we are going to graph these two equations. And the equations, the first one says y equals 1/3 absolute value of x. So we're looking here, we're going to graph this one first. I'm just going to write it down below. And then it says compare each graph with the graph of y equals the absolute value of x. So the number in front is the slope. Yes, it's listed as an A, but that A value is the steepness of the graph. This graph has two sides. It has one side with a positive slope, and it has the other side with that slope being negative. That's what makes the V. It's really two lines with a positive and negative slope connecting together to make a V. This graph has a vertex at 0, 0. Because there is not a number added or subtracted anywhere in the equation. There's just the number 1/3 in front. So the way we graph this is we're going to go to 0, 0. That's our vertex, and we're going to put a little point. And then you're going to apply the slope to that point. And I have to do that twice because there are two sides. So I'm going to graph the first slope, which is up 1/3. And then I would connect that side of my graph. I'm going to do the second slope, which is negative. Well, I could go down 1 and right 3, or I could go up 1 and left 3. And that's the direction we're going. So it has a negative slope, but I'm really applying the negative to the 3. So I'm moving up 1 and going backwards 3. So I should look at my two lines, and one line should go down from the left to the right. The other line should go up. So one should be decreasing, the other one should be increasing. Questions? So this says to compare the graph. How would this graph compare with a regular graph? So looking at what we said above, how could this graph compare? Brooke, how would you say this graph compares to the regular graph? if there's a 1/3 in front?
It's much wider.
Yeah, good. So the graph is wider. So that number in front is less than 1. It's a fraction less than 1. When that happens, we call that a vertical shrink, where the graph is wider. So we're going to see if we can do this, the second one for part B. We have a -2 and then the absolute value of x. The key thing is that the side on the right, that was supposed to be an A, is the original slope. So my original slope would be -2/1. The side on the left has to have the opposite slope. So the opposite slope would be a +2/1. So the right side gets the original slope, the left side gets the opposite. Your graph should always look like a V. So when I go to graph this, again, my vertex is at 0, 0, because there's no numbers added or subtracted. So now the left side is the positive, the right side is the negative. I'm going to graph the right side first. So I have a -2. That means I go down 2, and then I have a +1. Down 2, right 1. My other side, I'm supposed to have a +2 and a +1. Well, that wouldn't make a V. But if I go the opposite, if I go down 1 or 2 and down 1, backwards 1, sorry, I cannot speak. It's still positive instead of going up and right and going down and left. So I still have a positive slope. So when you look at your graph, it should always be a V, either a V that goes up or a V that goes down. It should never look like a greater than symbol or a less than symbol. We're graphing V's. If I want to compare this, I would say that it flipped. So it has a flip. And it's a little steeper or a little more narrow, whichever word you want to use. And that's because the number in front is bigger than 1. That 2 is bigger than 1, so it's more narrow. Questions? So we're going to try and graph one more. And this one has a whole bunch of numbers in it. So we're going to talk about these numbers. The first thing that I'm going to do is I'm going to look at this plus sign and I'm going to rewrite it as a minus sign. So this is really x minus and then -2. The reason I want to rewrite it is because the equation is supposed to have a minus sign in it. And then outside there's a -1. For every one of your homework problems tonight, I want you to list the vertex. That's part of your work, or whenever you do it over the weekend. Can anybody tell me what the two numbers would be that go in the vertex? So look at the two numbers in the equation. How would those two numbers make the vertex? So here are my two numbers. Ava, what do you think?
Would it be -2 and +1?
You're really close. What this symbol that goes with the 1 actually stays with it. The only one that
Oh, okay.
Yeah, so the only one that changes is going to be the h value. So it's going to be -2 and -1. So we're going to graph that point. I'm going to go over to -2 and down to -1. That's where my graph starts now. So every graph begins with a vertex. I need to focus on that vertex. The second part would be the slope. The slope is -3. On the right side, it stays the same. On the left side, it becomes opposite. So starting at the vertex, I'm now using the slope. I'm going down 3 and right 1 because I'm doing the right side first, and then I'm going to connect. I need to go down 3 and backwards 1 for the left side. So notice if it goes down, I'm still going down both times, except one time I'm moving right and the other time I'm moving left. So when you're graphing them, you're either going up on both sides, but you're going up left and right, or you're going down on both sides and then you're going down left and right. So I know I'm out of time. This graph flipped and then it moved left 3, nope, left 2, not 3. And then it went down 1. This would be explaining the transformation, which you're going to do with your homework. So I know that was a lot for a Friday. We're going to do more of this on Monday. I would like you to try your best that you can on the homework over the weekend. Also have a fabulous weekend. It's going to be 80 degrees and sunny, so enjoy the weather, and we'll see you Monday.
Bye.
Bye. Have a good one.
Happy Friday.
Hey, thanks. You too.